Hey guys, so our next lesson is on isotopes, so I just wanted to give you that information for the next section that you guys are doing. And I figured that I would record and we'll do some asynchronous notes like it looks like majority rules. All right, well, let's go. So for isotopes. So first of all, let's review some of the things that you guys already know, right? So you guys already know that the mass number of an element is going to be equal to the number of protons plus the number of neutrons in its nucleus. If an atom of the same element have different masses, they are said to be isotopes of that particular element. Isotopes of an element, they're going to have the same number of protons and electrons, but they're going to have a different number of neutrons. That is what makes them an isotope. So let's talk about how we name these different isotopes. So there are two different types of notations. The first one is going to be a hyphen notation. And hyphen notation is exactly what it sounds like. You're going to write the mass number, and then you're going to have a hyphen after the name of the element. So it's going to look like this. So for example, for the isotope of uranium that has a mass number of 235, you will represent that with uranium-235. Okay? It seems pretty simple. I just need to give you this knowledge so that you guys will be able to recognize the notation. The second notation is going to be a nuclear symbol notation. And for that notation, there is going to be a subscript that's going to indicate the mass number. And then there's going to be, a superscript that indicates the mass number. And then there's going to be a subscript that indicates the atomic number. So superscript is the one that is raised above the line that you're writing on. Subscript is the one that's below, obviously the name sub. It's going to look just like this, okay? So if we were looking at the same element, uranium-235, if you look, we have the symbol of uranium, and then here is the mass number, which is the superscript, so that's 235. And then here's the subscript on the bottom, which is 92, and this indicates the atomic number or the number of protons. Okay? So just as a review, the two types of notation are hyphen notation. When you see it, you're going to see the whole name of the element written out with a hyphen, and then the mass number after that, 235. When we're talking about nuclear symbol notation, you're going to see the abbreviation of the element with the 235 as a superscript, which indicates the mass number, and then the subscript is going to indicate the atomic number or the number of protons, and that's going to be down below here. All right, so let's talk about how we find the number of neutrons. The number of neutrons is going to be found by subtracting the atomic mass from the mass number. This should be a review from the worksheet that you guys did on calculating protons, neutrons, and electrons. So I just wanted to remind you of that little rule. So in an example like this, where we're using the nuclear symbol notation, remember 235 up here, that is going to represent the mass number. 92 down below is going to represent the atomic number. So to find the number of neutrons, I'm going to take the mass number, which is 235, and I'm going to subtract the atomic number, which is 92, which will leave me with 143 neutrons. Okay, so hopefully that'll be relatively easy. Please remember that you can always use your calculator if you need to for these types of notations. Okay, so let's talk about something that's really, really important. You guys are going to be doing a worksheet on it on Monday, I believe, and it's going to be on average atomic mass. So we talked briefly about carbon and that this number up top here, the 6 is going to be the atomic number, and then we talked about this number down here as the average atomic mass, right? So I want to go into a little bit more detail about where this number comes from. So this number is going to come from the isotopes of an element that all play a part in the element's average atomic mass, and they base it on how available or how abundant it is on Earth. So in other words, the weighted average of all of these carbon isotopes naturally found on Earth ends up being 12.011. Now you're probably asking me, how do we calculate that? Well, how you're going to calculate that is for each isotope, you're going to multiply the mass by the percent abundance. It'll make a little bit more sense once we go through the problem that's here on the slide. Then you're going to add the answers together to get the average atomic mass. At this point, it might be useful for you guys to have your calculator out so you can at least get familiar with how to use it and make sure that you get the correct answers. So here is an example for you. So there are actually 2 naturally occurring isotopes of copper. We have copper 63. Remember, we're using the hyphen notation. So we have copper, then the hyphen, and then we have the number after, right? Remember, 63. Okay, and it says that it makes up 69.17% of the copper on Earth. Then we also have copper 65, right? And for copper 65, it makes up 30.83% of the percentages of them on the Earth. So now it's going to ask you, well, how do you figure out that average atomic mass? So there is a process behind it. So step 1, what you're going to do is you're going to convert your percent to a decimal. To do that, you need to move the decimal point back 2 places. So that's how you end up with 0.6917. Now what you're going to do is you're going to times it by the number after the hyphen, right, which is that mass number, okay, and that's going to be times 63. Then we're going to add it to the percentage turned into a decimal once again of the other isotope, so that's 1, 2, so that's how we end up with 0.3083. We're going to times that by that mass number at the end, which is 65. And then we are going to make sure that we remember our rules of operation. So we're going to do the multiple choice first. So we're going to multiply these 2 together, and then we're going to add both of these numbers together. And the number that we get is 63.96. And the unit that we're going to use for average atomic mass is going to be AMU. All right. The problems will be a little bit easier once you guys start going through them, but that is all the information that I need you guys to know for today, okay? So I hope that was helpful, and I don't know, have a good day. All right, bye.